Hello, welcome to another free code session. My name is Jason Bach, and I'm going to do an episode talking about this problem yet again, but this is truly going to put it to bed. Not that it's the absolute best way of doing it, but I just want to stop. And I've said this now how many times, but isn't it true of developers and programmers that you keep thinking about a problem and you keep thinking about, well, how can I do it better? How can I do it better? How can I reduce the size of what I'm producing, or what the size of the executable is, or anything like that. It has been interesting because I've been watching some live coding streams from Jonathan Blow, and how he's been reducing not just the speed of what the compiler takes, and he's using a tool, by the way, called telemetry, which looks really, really cool. I looked at their site, which is kind of sparse, but it does seem like you could use it in C Sharp, but seems like it's geared primarily for C and C++. But I would be curious to see how it would work in C Sharp, because the tool itself seems really, really fast, really responsive, gives you a lot of good insight as to how your program is executing. So in any event, he's been trying to reduce the time of compilation with this language he's been working on for, I don't know, 4 or 5 years, whatever it is. And it's, even though a lot of it I can't follow, I don't quite get what he's doing, or the specific things that are happening in the compiler itself. It's just cool to watch somebody put the effort in to make something better and better and better, and that is a good thing. So, and I don't mean to say that because I've been thinking over this and just keep ruminating over a kind of a silly problem like this, that makes me a better programmer. But I do think there is some truth that if a developer is trying to think of how can I make this better, both in terms of readability, performance, size execution, all that stuff, I think that's a sign of a developer that's trying to go above and beyond just I'm going to bash it out, and I'm going to do something that's like literally the worst or something like this. But hey, it works. It eventually comes back with an answer, and then let's go push this off to some serverless asynchronous thing that will eventually give me the answer. And again, that stuff is fine, but I've just seen so many things of let's do something bad, and then let's put a bunch of band-aids and duct tape or flex tape, I guess is the thing these days. But do all this stuff to kind of and hold on, I just realized I didn't have this actually plugged in. Where did my power go? Power. Oh, this is power. Okay. I had this upstairs. Excuse me for 1 minute. Technical difficulties. I get this plugged back in. And I was like, why? This is also something I think I've mentioned in a previous thing, which is, there you go. Now, see, I don't know if you saw it, but now the screen's a little brighter. I was kind of wondering, why does this look kind of dark? And, well, now we know why. I've noticed that on websites, if I scroll in and kind of scroll back out, it's just something about the font size or the way it looks. I can tell, right? There's something wrong about it, and it keeps bugging me. Anywhere, where was I? So, I think if you're trying to make things better and better and better, rather than making them bad out of the gate, and just say, well, it works, it does what the requirement says it's supposed to do, and that's all I needed to do. I think that's missing. I don't want to say it's unethical. I just think you can always strive to do a little better. And I've heard, what's the phrase? Perfect is the enemy of the good. But I think sometimes, crap is the path of destruction. I can't come up with a good phrase right now. But realizing that you always have something to learn. There's always ways to make things better, and trying the best to make it better. In fact, I think I mentioned this before, but if I haven't, I've done a presentation on improving performance in .NET applications, and I've never quite been happy with the way the presentation flows, and I'm going to be doing it in VS Live Las Vegas in March, and I'm going to try to kind of keep some of the content there, but totally restructure it, and especially some thoughts I've been having around performance and apps over the past year or so. And basically say, you have two chances of making your app perform better. One is when you're actually writing it, and two, when you have to come back to it and realize you have a hotspot or something isn't quite working the way you expect it to. So if you can do things right out of the gate, then you're not prematurely optimizing. I hate that quote anyway, not the quote itself, but that people tend to misuse that quote or reinterpret it for however they want. If you can write things really, really well out of the gate, why wouldn't you? And what tools can you use to help? What tips can you keep in mind as you're writing code? And sometimes it's just experience. You get a feel for, I think this is the right way to go. But there's also times where you are rushed, or you just you didn't quite get it right, or something unexpected happens, and you look back and you're like, I gotta go fix that. So what things can you do then to make that job of improving the performance after you've gone live or you actually had something done? What can you do to find those hotspots? So in any event, so I'm going to go through something I did to improve this a little bit, and then I'm going to spend the rest of the time going through two books, just because I'll get to that. We'll talk about that when I get there. So because I'm still on a very long vacation over the winter holiday break, and I want to get an exercise routine in, and then my family, we're going to see the Spider-Verse Spider-Man movie, which I've heard is unexpectedly really, really good. When I saw a trailer for it, months ago, I was like, okay, didn't really know what to make of it, but I've heard just overall really, really good things about the movie. And so we're going to go to that, and then we're going to go out to dinner to our local Mexican restaurant, because yes, I like Mexican. So what did I do here? So my attempt here, one of the things I started realizing is, I think I've got this up here in one of these previous functions, is I was always taking that first number and saying, well, if the number itself is evenly divisible by 2, then just skip it. Or I'm sorry, if it's not, then go into it. You get what I'm saying? So I was trying to do this check at the beginning. And then I said to myself, well, should I do it by 3 and then by 5 or 4 or whatever? And long story short, I started realizing, well, this one, by the way, I checked is divisible by 9. And so why don't you just check to see if it's divisible by 9, and then if it is, then keep going. Which this is a slight optimization here in that I will check the number again, in a sense, even though I know it's divisible by 9, the first one. But never mind that. The point of what I was getting at is I started realizing, well, you only have to check every 9th number. You don't have to go through every one, because that's just wasted CPU cycle. So you notice here my for loop is now doing skip every 9th one. Yeah. And so that's what, again, makes this a little bit redundant. But this now speeds it up, because I no longer have to in fact, let me just check here quick. I'm going to let the benchmarking thing do its thing while I explain some of the stuff I've been doing here. Whoops, no, there you go. Switching the keyboard. Make sure that's going, and then we'll come back to the code here, and hopefully by that time, and there, okay. So that was one thing I noticed, is just skip every 9th number, and that made it faster. I think I was getting with the best ones up there was 2.3. Again, the best ones were these methods that were not written really well, but they had the least amount of memory allocation, and they were slightly faster than even this one, where even though this is a little messy, it's still, I think, easier to read. This still has slightly more memory allocation and almost as fast, but not quite. But the point is, by now eliminating to every 9th one, it's that much faster. And that would do the same thing if I did that on these two. you'd have the same benefit. So that was just another realization I had, which is you can skip all those. There's no point in actually having to do those. And I can feel my fan kicking in massively. This may not have been the best idea. How choppy is this video going to be? We're going to find out after I render it. Hopefully it should finish pretty quick. Yep, it already did. Good. So we'll talk about those results in just a moment. So that helped. And then I said, well, this is a CPU bound function. There's no I/O or anything like that. And I'm not using the hardware. There's just a stupid thing to think of. Why don't I partition the calculations and do them within tasks? So that's kind of what I did here. I created a local function that you give it the bounds of what you're supposed to look through. Okay, and then so this is all this relatively the same amount of code as before. Okay, except down here, I check out the number of processors, and I did this late last night, so I'm sure I could even improve this a little bit better. But I looked at my lower bound and upper bound, and then this weird piece of code here is basically saying, how many numbers do I have to go through every 9th number, so I can put those into a nice partition set of tasks based on the number of processors you have. Okay, and so that's what this loop is doing, and passing them into here. And of course, I forgot late last night. I didn't forget, but I did it wrong, which is I wasn't capturing the variables here, because doing it this way, if you're reliant upon the lower bound numbers being passed in here, they actually wouldn't be calculated until you get down to here, and then all of them got the same number, which is just like, duh, you're stupid. So that's why this is happening here. And then this last one here is because of the way this math works and how it truncates values off and stuff. You may not have gotten completely all the way to the top. So this one just says, I know I need to get up to here, so you may have to do 1 or 2 extra numbers, but that's fine. Go ahead and do that. Okay. So then I just do a task wait all, and then I get all the values and I put them in the finals array and return it. And I did check this, and it gives the right answer. Okay. So what does this do in terms of performance? Let's actually grab this and put it into my handy dandy Notepad++, and let's throw that down here. This is some of my chicken scratching notes. Excuse me. And you can see that with multiple tasks, it's not like divided by 8. I have 8 processors, so you can think, well, that should just easily divide into that, right? If I do my calculator and say, like, what, 815 divided by 8, well, it's kind of close. I mean, it's not quite there, but it's actually, closer than I expected, I guess. But the point is that you use the hardware you have on the machine. You have these days, everybody has a machine that has multiple cores, and if you can, well, then take advantage of them. Especially if you have CPU bound work. If you don't, even if you have IO bound work, you can still, have that all go off and do their own tasks and then come back later. So it does allocate more memory, but that kind of makes sense. Again, I can't do math in my head, so if I do 176 times 8, that's not quite there, because again, you have some work that's being done outside, but it does make sense that it increases because now you're doing 8 rather than doing 1 before. Okay, so that was another speed up, but I'm going to stop here because this is just, I've got, like I said, I've got other things to do. I'm going to be struggling just to get some of that DubSharp compiler stuff done before the presentation, and I have another presentation at that conference on metaprogramming, which I haven't done in a while, and I need to make sure the material is up to date and everything like that. So in any event, this has been fun, but I am going to literally close Visual Studio on this one, and it would be interesting if somebody comes up with a even a better approach. I'd be kind of interested to see what people do on this, because it's always fun to learn what other people have done and some optimizations they have done. I don't remember if I've ever done this in a stream, but there's a program that Quicksilver program that I did where instead of having an array that has the state in there of each piece in a particular position, I use a 64-bit integer, a uint, I think, and I'm sorry, ulong, and then use 2 bits in each value in there to represent the board state. So you had 25 pieces, 2 bits, 50. So you're wasting 14 bits, but you only have a 64-bit number rather than a 25, an array that's allocating 25 sections, slots, whatever you want to call them. And I thought I did a long time ago an analysis where it is slightly faster. I should revisit that at some point because it's not also just the speed, but it's the allocation of memory, and the fact that you're only using 64 bits compared to what a 25 enumeration value of an array or whatever that is was. So maybe someday I'll get back to that. But that's that. The other thing I want to do today is just quickly talk about, where are we at? 16. Okay, good. I didn't have my time here. I have a table that's usually sitting here, a little side table off my desk. And I've moved it because my older son, we gave him Axis and Allies and Zombies for Christmas. And if you've ever played games like that, they're quite complicated. And you need to set them up, unless you're going to spend literally a whole day playing it. You need to set it up and let it sit there. So we moved that over into an area downstairs, and we have that set up. We've been playing just like an hour a day. So games like that, that or like Risk or other games that take a long time, I tend not to do very well with because my attention span I can't sit there watching it. I also remember when I was in college, I'd watch my roommates and their friends play games like Axis and Allies and almost get into fights because they get into every detail of the rules and interpreting them and almost yelling at each other. And I remember one time when I was a senior in college, some Saturday I was sitting around reading and they were playing and they got into their fights and stuff. And then later on when they cooled down, they started, playing again. Or I don't remember what the circumstance was, but they asked me, why don't you play with us? Hey, what, you want to play? And I was like, no. I said, well, why not? And I said, because the way you guys act, why would I want to do that? Why would I want to waste a Saturday afternoon playing with you guys where all you do is fight about the rules? And they just kind of looked at me and they were like, oh. I don't find that enjoyable. I really, really don't. I like games, like chess, but other games like there's the whatever GIPH project. There's like 6 board games in that, abstract games. Ingenious, I love that game. That's a fun game. Terrace is another game I like. Those types of games where the rules aren't that detailed, and yet you can get kind of complex structured games going on. Those I enjoy. So any event, my table here is no longer here, so we're gonna have to hopefully end that game at some point, or I have to get another table in here to put my stuff on. So I don't have all my stuff here. It's over here. The thing I wanted to talk about is like what books have been really helpful for me, or material. And I say books because remember, I'm old, and I haven't always bought books, of course, over time with internet and digital media, with blogs and streaming and a host of other things to disseminate information. In some ways, it's made a book, I don't say obsolete, but it kind of is, But at the same time, I've just that's one of the things I'm going to be a curmudgeon on. Is I just love a book. I love opening books. I have a pretty decent sized collection of books, and I figure if I have an addiction, books is probably a good one to have. So, but one of the things I wanted to talk about just real quick is what are some books that I felt have influenced me as a software developer in a good way. And there's lots. I've read lots of books in software development. They're all good or sometimes not so good. And, they are what they are. I just wanted to talk about 2 books real quick that I think helped me as a software developer and made me a better software developer. So the first one, maybe kind of an odd choice. Not a lot of people, I think, have heard about this book. Because it doesn't seem like, I remember back in the 90s, everybody was like, oh, design patterns and And that's, I think Grady Booch's book on object-oriented programming, which of course it's funny these days how people, I've noticed, just diss on object-oriented programming, and I get why. There's lots of good techniques, and to me it's, use what you know, and also use what you don't know, and learn about new things, and do things better. And it's funny because as a C# developer, I don't always program with an object-oriented mindset. There's times where I just do it fairly procedurally. Again, do it to what works best with the context of what you're in. In any event, though, this book, which I want to make sure I've got got it in camera and it's not glaring too much. It's not object-oriented. Come on, get the D in there. What the heck? There we go. Object-oriented design heuristics, Arthur J. Reel. And I don't know if he ever wrote another book. And the thing about this book, this is actually the second one I think I read after the one I'm going to talk about in a moment. But the thing I liked about this book is that it's heuristics. It's not do or do not do. And that's a danger, I think, in software development when somebody's like, well, what are the best practices? What are the things that we're supposed to do as software developers? Tell me what I should do or shouldn't do. And one in a very black and white mindset, and because this is the way we should do it. Somebody's told me to do it this way, so therefore I should do it this way. And it's not that patterns and practices and those types of things are bad. I don't want to put them down wholeheartedly and say that that's the wrong way to approach software or the way to think about software. But the danger, and in fact I've seen this recently at a client, which is, well, this is our pattern, this is our practice, this is the thing that we do, this is according to our guidelines, so this is the way we should do it, without having the flexibility in there to go, well, this is the way we did it, but it's not working so well, so maybe we should look at doing something different. I've always said having blueprints, good patterns, good practices in place, that people do things in a consistent fashion are good, because then if you find a way to do it better, you can do it consistently better. If you do things consistently, then if you find a better way to do it, you've done it consistently bad, quote unquote. And therefore you can probably refactor things in a much easier way. Whereas if everybody's doing everything their own way, then to try to track down how to change things becomes much, much harder. So yes, I do believe styling, patterns in code, approaches, doing those things in a consistent manner is a good thing. But that's what I liked about this book, is that it has a lot of heuristics, but it doesn't mean thou shall or shall not do this. It just says basically a lot of things to consider. And yes, even there are times where you can really say you want to do it this way or you don't want to do it this way. But I think in the long run, it's the context of what you're in. That's what matters. And so these are heuristics to keep in mind. And one of them that's always I've kept in mind from the book, out of any one of those. In fact, I was looking through it and going, I should probably review this. It's a refresher. I wonder how much of those things I still agree with or don't agree with. But the one in there that really struck me was don't do avoid the God class. And what the God class is if you are programming in object-oriented languages, is that you have a class that essentially is doing everything and knows everything. And I was writing a piece of software that I unfortunately realized, I kind of written it that way, where there was one class that kind of had every domain, every concept built into that thing. And it was funny because that program I was on and at that client was for about a year in '97, and someday maybe I'll talk about that project, because it was a very learning experience as a young developer on things. But eventually I moved from that client to a different one, and years later I ran into the guy that they brought on from the consulting company to basically backfill me and continue on with the program. And it was like 5 or 6 years ago, I was speaking in Chicago, and he was there, and he came up to me, and it took me a second to remember who he was. And as soon as I remembered him, I went, "I'm sorry. I'm sure I gave you a program that was probably not the best to maintain or anything like that." And I knew that I had done that, where you just basically throw in the kitchen sink, do everything in one spot. Well, now, why did you just do that? You're not putting things in the right places, parceling them out. It's just a good, if you throw everything into a room in one spot, then you have all this other room in your house. Why don't you put things in different places and not have everything just shoved into one spot, because now it's harder to find stuff. And so that one's always struck me as, don't do everything in one spot. So it was a good book, and it really made me think differently about how to design object-oriented systems, and not always to be so pedantic, and not always try to do it, in such a way that you never move off of a certain way of doing it. You can always learn more. And so for some reason that book just really struck me. But another book before that I had read, which I think it may even be dated at this point, I'm not sure, but at the time, this really made me think differently about coding, which is Code Complete, and that is by, can you see his name? Steve McConnell. This is a fairly famous book. What edition is this? Like the first edition? I'm not sure. I don't even have I usually put my name in a book that I buy, and oh yeah, I did, and I have a check mark because reasons. But this was really, really good, because when I was doing software development as just in my life, I just did it. I did it as kind of enjoyment, but I never really knew how to do it well. I started playing with computers in 7th grade with an Apple IIe, but while I found it cool, it didn't become an obsession in some ways. I know some people have said like they saw an Apple IIe or they got a Commodore and that like became their life. That's like all they did, and that, they knew they wanted to play with computers the rest of their lives. I knew technology was going to be a part of my life, but I didn't necessarily get into software development. Unfortunately, in my school at the time, we didn't have great courses on software development. So it never really grabbed me until about my senior year in high school and college. And then in my master's days, or getting my master's thesis, was basically writing a computer program to calculate pi, which I still have up there in my shelf over here. And I've gone back and looked at that code, and it's horrible. It's just, I can tell just by looking at it, it's like, this is just a complete mess, but it worked. Calculated the number. So there you go. When I was also in college, I remember working with somebody over the summers that I would work in the engineering department. My dad was a salesperson there, and so I would get some experience working in engineering. I was working in the lab, and this guy was writing this program to basically capture PV diagrams off of an air compressor. And I would look at his code, and it was just a mess. It was just bouncing go-tos, go-subs all over the place. He was doing it in Quick Basic. And it was just a complicated nightmare. And I think I went back and went through the code and cleaned it up a lot, so that became a lot easier to compile and read and understand. But again, this was just kind of playing. Once I finally got a job out of college and doing software development, I'd say for the first year and a half, I really struggled in the sense that I it's kind of like the dog. I don't know what I'm doing here. Just trying to get things to work, doing literally the worst thing I've been showing before, but trying in any way just to get something to come back. And I didn't understand database interaction. I really had never done anything with SQL. And so I didn't understand optimizations. I didn't understand how to make queries faster, or just software design, UI interactions, none of that. It was, here's a program that somebody wrote, we want you to basically maintain this and add things to it. And it was hard. Enjoyable, but hard. And then when I became a consultant in '97, I was still kind of in that same boat where I still didn't quite grasp, how do I make things better? How can I, make things so that I'm doing things in a good way? And I found that Code Complete book, and that really made me think differently about software development and just, in naming. It sounds weird, but names matter. Naming methods, naming variables, naming classes, naming what files, whatever you have. It helps so much if you put them in such a way that you can go back and go, oh, I can read this and kind of know what I was doing. And that sound like the book is so thick. It's like, why did I bring up naming? But there's so much in that book that I would sit there, and as thick as that book was, I would read it constantly and learn about things and just how to write code in a better way. Now again, that was in 97, 98. At this point, it might be a little dated. I haven't gone back and really looked through it since, but I do know it made an impression on me, and I think it made an impression on me for the better, and starting to make me think about how to structure programs, write software that was better than what I was doing before. It started giving me guideposts, guidelines, things to think about, things to start moving in a better direction to write code so that it wasn't just a hodgepodge of spaghetti. And I think that's been a good thing in my life. So while those books in 2018, almost 2019 at this point, may not be as relevant in terms of the technology or the things they're talking about, I think the concepts still hold true, and they were definitely seminal. There were definitely things that made me kind of look in a different way, perceive things in a different way, and I think they made me a better developer in the long run. So there's lots of other books I have that I could talk about and that I've read and have been good or decent, but those two really stick out in my mind primarily because of when I read them and where I was as a software developer in my career, and really I think helped me perceive things in a better way and be able to approach software and how I'm learning and not be so picky about even though I've been in C# for so many years now, to say it's not the language, it's not the library, it's not the package, it's not the anything like that. Those help, but it's these meta concepts, it's these things that go above all that stuff that you need to think about. And so when you go into a particular way of doing things, there's things that just translate between all these different languages and all these different ways of approaching it. And some do things better and some do things worse and some do better than what you're currently in. And it's kind of good to look at that stuff and learn and go, okay, what do I like about that stuff or what don't I like about it? And if I don't like it, well, why? Is it my own bias or is there something truly not good about it? So those I think really helped me in the beginning of my career, and I think giving me a better approach on software development. So I think I'm at time here, and I am, which is good. So I'm truly going to put this to bed. I'm not going to go back to this thing anymore. I'm going to start working on the compiler, and I might actually do it without live streaming some of the stuff right away, because a fair amount of it might be me just kind of literally flailing around really, really badly. And I might actually do some stuff offline and then do what I did today, which is just kind of go through it. I don't want to do that too much because the point of this is to actually show how I'm doing things in real time and the struggles that I have and what I'm just sitting there thinking sometimes. I know that's a boring thing to do in videos, but that's kind of the intent of this, is to show this isn't necessarily instructional in some ways. Again, I mentioned Jonathan Blow. Some of the things I noticed in his video is that, he just sits there sometimes and thinking, and that's fine. That's what we do as software developers. We sometimes have to just sit there and think, or just get up and walk away and come back, and that's what I was doing with this. Just walking away would start making me go, what could I do to make this even better? So this isn't like an instructional paid for video where everything's cut nice, clean, and presented really, really well. I'm trying to do well, but it's not the intent to have that type of instructional video. This is just me having fun. So, but that being said, with some of the stuff, I think I do need to play around with the core stuff and at least trying some things offline where it's not a bunch of quiet. So we'll see. The next video will definitely be on something to do with dub sharp and hopefully getting some results. So that's all I'm going to do today. Thanks for watching. Leave your comments and questions below. See you in the next episode.